Hi, this is Miss Logan. Today I will be talking about projectile motion. This is part 1 of 2 videos. Okay, so a projectile is any object that is projected by some means. So that means it's moving in both the x direction and the y direction. It's going to continue to move due to its own mass and will only stop if something else stops it. So this could be the ground, it could be a wall, something has to stop it. So projectiles are moving in 2 directions. They are moving in the horizontal x and the y. We need to always have 2 components to our problem, one in the x and one in the y. So the horizontal x component, my velocity will never change. The initial horizontal velocity is going to equal the final horizontal velocity. But why is this happening? Gravity is not affecting the horizontal or increasing or decreasing it. So my VF will always equal my VI. In the vertical component, our changes are due to gravity only. Our initial velocity will be 0, and our acceleration will always be negative 9.8, just like the vertical problems we've always been doing. For horizontally launched projectiles, we are going to have some initial velocity and final velocity in the x, but they are always constant. So if it starts out at 3 meters per second, our final will be 3 meters per second. However, in the y, our initial velocity will always be 0 meters per second. We will also have our acceleration equal to negative 9.8 meters per second. So to solve one of these problems, we need to follow these steps every single time. The first thing we will do is draw a diagram. So if a ball is being launched off a cliff, we need to show that projectile, then show what's going on in the x and the y direction. You'll see in our examples that we'll also write down what we know. Then we need to write down our known and our unknowns in our x and our y directions. I like to use this table every time to solve it. First, I'll look in the x, what do I know? And then what do I know in my y? It is extremely important that we separate these two. Then you'll determine which equation to solve and solve the problem. Okay, let's do our first practice problem. We are only going to set it up. We're only going to figure out our answers in the x and the y direction. So you were taking a running leap off a high dive platform. You were running at 8 meters per second and you hit the water 2.6 seconds later. So I have my high dive here. I am walking off and going down. Okay? So I have a starting velocity of 2.8 meters per second and my time is 2.6 seconds. Sounds good. I am looking for how high this distance is, and I'm also looking for my horizontal distance. Okay, let's set this up. So we know in the x, my initial and my final are both equal to 2.8. Nothing else is affecting it. We also know my time is 2.6 seconds. This is both for the x and y. I'm looking for my distance. In my vertical, I know my initial velocity is 0, my acceleration is 9.8, and my time is also 2.6. I'm also looking for my distance. So right here we solved about half of the problem. Our next step would be choosing the equations and solving for our 2 variables. Alright, so let's actually solve it this time. So a pole ball leaves a table that is 0.6 meters high with an initial horizontal velocity of 2.4 meters per second. Predict the time that is required for the pole ball to fall to the ground and the horizontal distance that it will take to fall off. Okay, so let's actually draw this out. So I have my pole ball and it's going to fall down this way. I know my initial velocity is equal to 2.4 meters and my height is 0.6 meters. I am looking for my time, and I'm looking for this horizontal distance right here. Let's write down our knowns and unknowns. In the x direction, my initial and final velocity are exactly the same. Nothing else is affecting it. My time I am looking for, and same with that horizontal distance. In the y, I know my initial velocity is 0, my acceleration is negative 9.8, and my distance is negative 2.4. It's traveling downwards. And I'm looking for my time. All right, so let's solve this. Okay, so in the y direction, we need to start solving that first. So based on what I know, I'm going to use this equation, which we will often use to solve in the y. Don't have an initial velocity. Let's plug it in. We are going to solve for t and get 0.7 seconds. Awesome, now we can go into the x direction. Remember, in the x direction, my initial and my final velocity are known. Now I have my time, so let's solve for distance. We will often use this equation in the x direction. Plug in my numbers. For my final distance, I'll get 1.68 meters, and that's in my horizontal x. All right, so pause this video and answer your follow-up questions. For 4 and 5, setup only, you're going to draw them out and do your x and y components. If you would like to challenge yourself and try to solve, you can do that as well. Make sure you take a picture of your follow-up questions and upload it onto Google Classroom. Bring any questions you have to class. We will be working with these equations all week.